Hi everyone, today we're going to be looking at variables. As the lesson, you're going to plan and carry out an experiment, but to do that you need to have very good understanding of variables, including independent variables, control variables, and dependent variables. That word variable confuses so many people, and yet it's central to everything that we do in science because you want to find out how changing one thing affects another. The word variable comes from the word to vary or to change. A variable is something that we can change, and in science we want to find out how one variable affects another variable. Let's start by thinking about cause and effect. The cause is what makes something happen, and the effect is what happens as a result of changing the first thing. That's all we're doing in science. We've got a cause, which is our independent variable, and we've got effect, which is our dependent variable. As scientists, we want to find whether your independent variable affects the dependent variable, and to what extent does the independent variable affect the dependent variable, so that we can find patterns. Here are some examples of causes and effects. Let's suppose I've got a pencil. If I sharpen the pencil will become shorter. The cause was sharpening, the effect was the pencil getting shorter. Another example would be that if you burn a candle, the longer you leave the candle to burn, the shorter it will become. You could also think about the number of car crashes that happen and look at how that relates to the colour of the car. The colour of a car, if it's very dark, might affect how many car crashes it would have because they might be more difficult to see. Another example would be when you drop a plate and it smashes on the floor. Dropping it would be the cause and the effect would be the plate smashing. But there are lots of other variables that could affect whether the plate would smash. One variable might be what material it's made out of. Another would be how high you drop it from. Another one would be whether you dropped it or you threw it onto the floor. There might even be a soft rubbery floor on the ground, which would mean that the plate wouldn't break at all. This is why, in a scientific investigation, you want to be able to work out what one specific variable you're investigating and try to control and rule out all the other variables. In the plate smashing example, we could ask the investigation question, how does the height affect how likely it is that a plate would break? Our independent variable, the one that we're changing, which is the cause, would be the height from which we drop the plate. The effect would be whether or not the plate smashed. All the other variables that we mentioned before have got to be kept the same. So we'd have to keep the material of the plate the same every time we dropped it. We'd have to make sure that we dropped it every time and that we didn't throw it because that would make it unfair. And we'd also have to make sure that we keep the floor surface the same. We'd then carry out this experiment, dropping the plate from different heights to be able to come up with a pattern or a conclusion. In a more typical science experiment, you might want to know how the temperature affects the rate of reaction. Rate of reaction is quite broad, so you'd have to think of a way to measure the rate of reaction, and that would depend on the chemicals being used. Let's suppose that we've got two chemicals, and when we mix them together, they become cloudy. We could measure how quickly the reaction was taking place by looking how quickly you could no longer see below the surface. We sometimes call this the disappearing X experiment. So we're trying to see how does temperature affect how quickly you can no longer see the X. Things that might affect how quickly you can or cannot see the X might include the concentration of the chemicals that you've got. If you've got a solid reactant, it might be that the different surface area of the reactant has an effect. The volume or the mass of the reactants would have an effect. The X and how dark it is when you put it underneath the conical flask would also impact on how long it took before you could see it. Therefore, when you carry out this experiment, you've got the independent variable, which is the temperature, the dependent variable, how long it takes to no longer see the X, and all the other variables are control variables. We have to keep these the same. By knowing what our dependent and independent variables are and the variables that we need to control, we're able to plan and investigate the question effectively. Here is the method for this experiment. Before we read through this method together, pause the video here and take a moment to read through. See if you can identify where it talks about the independent variable, the cause of the change, or what we input, the dependent variable, what we're going to measure, and all of the control variables, things that they want you to keep the same every single time you repeat the experiment. So, looking at this experiment, it says to start by using a measuring cylinder to measure out 10 centimetre cubed of 0.1 molar concentration sodium thiosulfate. The 10 centimetre cubed tells us that we need to keep the volume the same, so that's a control variable, and it tells us what concentration to use, so there's our control variable. Next, it tells us to gently heat the sodium thiosulfate using a Bunsen burner until it reaches 20 degrees C. That is our independent variable, what we're going to be changing. Check the temperature with the thermometer. Sorry, I've just noticed that typo there. So it should say put the conical flask over a piece of paper with an X on it. That's the X that we talked about before, that's underneath our conical flask. We wanted to make sure that when it's underneath, the X stays the same, because if it's a really wide, dark, thick X, that's going to take longer to disappear than a really pathetic thin X. Add 5 centimetre cubed of 1 molar hydrochloric acid to the sodium thiosulfate. Again, it's talked about the volume to use and the concentration to use. Immediately start the stop clock. Swirl the mixture 3 times to ensure that the solutions are properly mixed. So again, we've got more of these control variables. Look down at the cross from above. So again, that's telling us how we're actually going to do the procedure to make sure that we do the same method every single time. Stop the clock as soon as you can no longer see the X and record the time taken. That is our dependent variable. We can tell as well that it's the dependent variable because we don't know what the answer to that is beforehand. Whereas our independent variable, which we've got again over here, repeat the experiment heating the thiosulfate to 30, 40, 50 and 60 degrees C, we know what the temperatures are beforehand, or we've got a rough idea at least of what they are. To get reliable results, repeat the experiment 3 times at each temperature. So whenever we're repeating results multiple times and finding an average, that's always for reliability. It means that we can see if one of our results seems a bit dodgy, it doesn't quite fit the pattern, maybe we've done something wrong in the procedure when we were doing it. When we get one of these dodgy results, so something that doesn't fit the pattern, we call it an anomaly. And we generally don't include our anomalies when we're finding averages. So when you look at your method as a whole, it will always include your independent variable, and that's always mentioned right towards the beginning and towards the end of your method. To make sure you include it, some people like to prefer to say right at the beginning, they repeat the whole experiment using temperatures 20 degrees, 30 degrees, 40 degrees, etc., so that you make sure you get that point in. It'll always say somewhere what your dependent variable is and how you're going to measure it. Lastly, it will have to include all of your control variables, which will be throughout your whole method. So whenever you're planning an investigation, I really recommend you think about that little diagram. You've got your investigation question, which is central to what you're asking. Going into it is your independent variable, the thing that you think might cause something to happen. At the end of your experiment, or coming out of your experiment, is your dependent variable, the effects that you think it's going to have. In the middle are your control variables, all the things that you're going to have to keep the same to make sure that it's a fair test. Being able to understand what each of these variables are and why we need to use them is really important whenever you're planning any kind of investigation. Make sure that you can do this for any experiment that you do.